All right. Anybody have any questions about the class structure or any of the stuff we talked about last time? Okay. Well, today we're going to get into some material. We're going to start with unit conversions, scientific notation, unit prefixes, that kind of stuff. I know a lot of you have seen this stuff in probably chemistry before, but we're going to do it again. So we're going to start with just talking about units and converting between units. So every physics measurement has some kind of unit attached to it. You can't give the speed of a car by just saying 50. I mean, you can because people will assume you're talking about miles per hour most likely, but there has to be a unit associated with any measurement that you mention. All the units in this class are going to be combinations of just 3 basic unit types. So all the units in this class are combinations of 3 unit types. Those are length, and units for length would be, millimeters, inches, meters, miles, light years, so on. Units of time. So that would be seconds, minutes, hours, years, and units of mass. In the units that we're used to, we don't talk about mass very much. In SI units, the units that we're going to use, the units for mass are kilograms. If you're using units of pounds, feet, that's like English units. The unit for mass is not pounds. I think a lot of people would maybe assume that it's pounds, but it's actually slugs. And it's something that doesn't really come up in daily speech. But we're going to do basically all of our calculations in SI units. So that means our units of length are going to be meters. Our units of time are going to be seconds. And our units of mass are going to be kilograms. So these red ones are SI units. You can think of it as standard international. It actually stands for like a French version of that, but it's the international unit type. And so these can be combined. I mean, you've seen units of speed. You're familiar with those, are a unit of length divided by a unit of time. In SI units, it would be meters per second. We're used to miles per hour in the US. And so often, if you want to know how you're putting carpet in a room or something, and you want to know the measurements of the room, and someone gives it to you in feet, and then you get to the website and it's in meters, it's often necessary to convert from one unit to the same type of unit in a different system. Okay. So often we want to convert to a different unit of the same type. So for example, how many inches in 5 miles. And so to do conversions like this, we're always going to follow the same approach. And the general approach, the basic approach is there's always going to be a unit conversion that you're going to use. So there's always a conversion between the unwanted units that you're given and the desired units. So for example, boy, I didn't plan ahead on this one, but in this example, how many inches are there in 5 miles? You'd need some kind of conversion that lets you know, you'd need a conversion that goes from miles to inches. Let me calculate that real quick. So, okay, so for example, 1 mile is 63,360 inches, okay? Now notice, since those two are the same thing, you can write those two as a fraction with either one of them in the top and either one in the bottom. And that fraction is dividing something by itself, okay? And if you divide something by itself, you get 1. So, so this leads to 2 conversion factors. Factors because we're going to multiply it to stuff. And these 2 conversion factors are 1 mile over 63,360 inches. And like I said, that's equal to 1 because you're just dividing something by itself. And that's also equal to 63,360 inches divided by 1 mile. Okay? And so you are going to start with what you're given and then multiply it by the conversion factor that cancels the unwanted units. And that's really the whole approach to unit conversion. So if we're starting with 5 miles, we want to multiply that by either 1 mile over 63,360 inches or 63,360 inches over 1 mile. And we want to choose the one that's going to cancel miles. We're going to think of the units as, the math of the units is like their algebraic variables, okay? So since I have this factor bar, let me just write it as, you can think of this as 5 miles over 1, right? Think of it as a fraction. The miles is in the numerator of this fraction, right? So we want the one of these 2 conversion factors that has miles in the denominator to cancel this. So I'm going to multiply this by 63,360 inches over 1 mile. And now again, if you think of those units the same way you think of algebraic variables, this one up here cancels this one down there, and the units we have left are inches. And now all you have to do is multiply out these fractions. 5 times 63,360 gives you a total of 316,800 inches. Okay. What would happen if I would have used the other conversion factor? So if I started with 5 miles and I multiplied that by 1 mile over 63,360 inches, you can see nothing cancels because the miles are both in the numerator. And so we get this thing that's 0.00007891. And the units are miles times miles, which is miles squared over inches. And there's nothing wrong about that, but that isn't, and actually, if you wanted, you could use miles squared divided by inches as a unit of length, but no one would ever want to do that. It's sort of a crazy unit. And so that's what goes wrong if you choose the wrong conversion factor. Okay, nothing cancels and you just get this ugly combination of stuff. When I do these problems, instead of writing these out as fractions with parentheses, I'm going to always write it. Okay, so let me cross this out just so. I'm going to write a big fraction bar. And then I'm just going to, instead of parentheses, I'm going to put vertical lines to separate the different factors that I'm multiplying. So I'm going to go, so this is what I'm starting with, 5 miles in the numerator. And I'm going to multiply it by 63,360 inches over 1 mile. And this means the same thing as this. Okay, so that's just a notation I'm going to use to save some pen strokes as I go. But you get the same thing. So if you multiply this out, you'd get 316,800 inches. Okay, well, that is a conversion of, so that's a conversion from miles to inches in one step. You also can do these in multiple steps. So let's see how this works. So let's do the same conversion. But this time we're going to use the fact that 1 mile is 1,760 yards. And 1 yard is 3 feet. And 1 foot is 12 inches. Okay? And we're going to do that same conversion. In this case, the approach is just going to be, we're going to multiply by a conversion factor that takes us from miles to yards. Then we'll just keep multiplying the same thing by a conversion factor that goes from yards to feet, and then from feet to inches. So we'll have 3 conversion factors in the same calculation, okay? So we're gonna start with 5 miles again. When we're done, we better get the same answer, because there either is a single answer for this or there isn't. So from miles to yards, we know we're going to use either 1 mile over 1760 yards or 1760 yards over 1 mile. Do we want the miles in the numerator or the denominator of this conversion? Yep, we want it on the bottom. So we got 1 mile down here, 1760 yards there. And you can cancel as you go. Those miles cancel. And now we're in units of yards. So we're getting there, but we're not there yet. Now we're going to multiply, since we're in units of yards, if we multiply these numbers out, we're going to multiply by a conversion factor that goes from yards to feet. So do we want 1 yard over 3 feet or 3 feet over 1 yard? Yep. So now for this one, the unwanted unit is the yards. So we have 3 feet over 1 yard. And those cancel. And now we're in units of feet. And then the last step, do we want to multiply by 1 foot over 12 inches or 12 inches over 1 foot? Yep, so again, we want to cancel the feet that are in the top. So 1 foot goes in the bottom, 12 inches goes in the top. That cancels that. The only units that are left are inches, so that's the units that we're in. And if you multiply this out, you get the same thing back, whatever it was, 316,800. Okay. Anybody have any questions about that? Okay. Another thing that can happen is the units for our starting quantity was just a single unit type. It was just a unit of length, right? But you can have combinations. So now let's do an example. Where we want to convert 61 miles per hour into units of meters per second. And we want to use the conversions that 1 mile is equal to 1609.344 meters. And 1 hour is equal to 3,600 seconds. And the approach is going to be pretty similar to this last example we just did. We're going to first multiply it by a conversion factor that gets rid of the miles and converts it to meters. And then we'll multiply by a conversion factor that goes from hours to seconds. Okay? So we'll start out with 61 miles. And notice that you have to be very clear about what's in the top and what's in the bottom of the fraction. The 61 and the miles are in the top. The hours are in the bottom. And it doesn't matter which order you do this in, but I'm going to go miles to meters and then hours to seconds. Okay, so to convert from miles to meters, do we want 1 mile over 1609 meters, or do we want 1609 meters over 1 mile? We want, since the miles that we're starting with are in the numerator, we want the miles of our conversion factor to be in the denominator. So I'm going to go 1609.344 meters over 1 mile. And then you can see the miles cancel. If we multiplied the numbers out now, we'd have units of meters per hour. So we're getting there, but now we have to convert the hours to seconds. And now, to convert hours to seconds, do we want 1 hour over 3,600 seconds or 3,600 seconds over 1 hour? The key thing is that the hours that we started with, this time we're in the bottom, right? They're in the denominator. So our conversion factor needs to have the hours in the top of the fraction. So we're going to go 1 hour over 3,600 seconds. And now you can see this hour cancels with this hour. And the units that we have left are meters in the numerator and seconds in the denominator. Okay? Now that you have the right units, you can just multiply everything out, and this comes out to be 27.26 meters per second. There's really only one other thing that can come up, and that is that when you have these combinations of units, one or more of these units are squared or cubed or something like that. Okay, so let's see how to do that. So let's say that we want to express 38,640 yards per minute squared. In meters per second squared. And we're going to use the fact that, or the facts that 1 yard is 3 feet. 1 meter is 3.281 feet. And 1 minute is 60 seconds. Okay, so in order to do this and not make mistakes, what you want to do is make it clear to yourself that that minute squared that's in the denominator of that fraction is really a minute times a minute. And you're going to have to cancel each one of those, okay? So, so we're going to start with 38,640 yards over minutes times minutes. You can go in any order, but I'm going to do the yards to meters first. So first I'm going to go yards to feet. Then I'm going to go feet to meters. To go from yards to feet, I'm going to go 1 yard in the denominator, 3 feet in the numerator. That cancels the yards. And now to go from feet to meters, I'm going to go 3.281 feet in the denominator, 1 meter in the numerator. So that cancels those. And now our units of length are meters, so we're getting there. And now to convert the minutes to seconds, we want to go 1 minute in the numerator, 60 seconds in the denominator, because that cancels one of these minutes in the bottom of what we're starting with. But the easiest mistake to make with these kind of problems is to think that you're done at this point, okay? Notice that if you do the cancellations, you can see really clearly that one of these 2 minutes from the minutes squared still hasn't been converted. The units that we would have if we multiplied out these numbers right now would be meters per minute seconds. Okay, sort of a weird combination unit. That's not what we want. So we have to do this one more time to cancel the other minutes. So we have 1 minute over 60 seconds. And so cancel that, cancel that. And now our units are meters in the top, seconds times seconds in the bottom. And so if we multiply this out, we get 9.81 meters per second squared. Does anyone from a previous physics class or anything know what the units of meters per second squared, length per time squared represents?
The volume?
It's acceleration. And this number is one that we're going to see all the time. 9.81 meters per second squared is the acceleration of any object that's in free fall. So if something's, or in projectile motion, if something's flying through the air and there's not much air resistance on it, this is the acceleration down that's happening. So that's going to come up in 1 million calculations in this semester. Okay, that was like a whirlwind tour of unit conversion. Anybody have any questions about any of those? Let's, I'm going to write down an example problem, and then I'm just going to give you a couple minutes to work on a problem. Okay, so let's say that okay, the density of steel is 7,000 kilograms per cubic meter. Given that 1 meter is 3.281 feet, what's that density in kilogram per cubic foot? All right. So we're going to start with 7,000 kilograms. over meters cubed. So meters times meters times meters. You can see that the units we want have kilograms still in the numerator. So we don't have to mess with the kilograms. That's already good. But one by one, we're going to have to convert the meters to feet. Okay, so the first meter, I mean, each one of these meters is in the bottom. So our conversion factor is going to have meters in the top. So we'll have 1 meter over 3.281 feet. That cancels one of these. Then do it again to cancel the second one. Then do it one more time to cancel the third one. And if you look at the units that are left, we have kilograms in the numerator, feet times feet times feet in the denominator. So we know our answer is right. We just have to multiply and divide out the numbers. And this should come out to be 198.19 kilograms over cubic feet. Anybody have any questions about that? Okay, one thing people ask me about around this point is, what about significant figures? Do I care? You know, how much do I care about that? What do I want you to round to? I know, like in chemistry classes, you've sort of had it pounded into you that you have to be really careful about significant figures. I'm not worried about that. I know you get that in other classes. So I'm never going to take points off for how you round anything. I just want you to, to follow the right procedure for it. So you could call that 198 or 198.2 or 198.19. It's all the same to me. I just want to see you follow the steps right. Okay, so that's about it for unit conversion. Now we have to talk about scientific notation. So the idea of scientific notation is that any number can be expressed as one non-zero digit, then a decimal point, then a decimal, times 10 to some integer. So for example, you could write negative 3,481.9 as negative 3.4819 times 10 to the third. And you could write 0.0087 as 8.7 times 10 to the minus third. Okay, so you can do that with any number. If the absolute value of the number is smaller than 1, that exponent is going to be negative. And if the absolute value is bigger than 1, that exponent is going to be positive. What are the benefits of scientific notation? The main benefit of it is it's a much more trouble-free way to write very big numbers or very small numbers. And in physics, very big and very small numbers come up pretty often. You know, like if you're doing calculations about orbits of planets, you're dealing with just enormous masses. You know, the mass of the Earth is something times 10 to the 24th power kilograms. Okay, so how are you going to write that? You know, you would have to write a number, and then you'd have to carefully count out 24 zeros before you got to the decimal point. And if you miss any of those, you're off by a factor of 10. You're not off by some little amount. I mean, it messes up the whole calculation. So it's a lot, when you're dealing with numbers that big, it's a lot less problematic to just have a number multiplied by 10 to the, you know, whatever the exponent is, 24 in that case. The other thing that's sort of nice about scientific notation is however many digits there are before the 10, that's the number of significant figures. So I don't know if you remember going through significant figures, but like I remember in school learning like, okay, you count the zeros unless they're before a decimal point, but if there are numbers then after the decimal point, you still count them, and you like, it's kind of confusing. It's really easy if things are given to you in scientific notation. So how many significant figures in this first number? 1, 2, 3, 4, 5, and that's the end of it. How many in the second one? 1, 2, and that's the end of it. So that's a nice thing about scientific notation too. All right, well, to use scientific notation, we need two skills. We need to be able to go from standard numbers into scientific notation, and we need to be able to go from scientific notation into standard numbers. If you're comfortable doing this, you absolutely don't have to follow what I'm going to tell you, but I'm going to give you a way that works if you don't have a way that, you know, if you're not too familiar with it or whatever, you just want a new approach. So, okay, you need two skills. The first one is given a number in standard notation, express it in scientific notation. Okay, so there are two steps for doing this. The first one is count the number of places. I'm going to call that number that you count capital N. So count the number of places N that you have to move the decimal point. Let's say to move the decimal point So you have one leading digit, one non-zero digit before the decimal point. All right, well, I'm going to go through sort of an example as I do this. So my example is going to be in red. Let's say I'm starting with the number 541.6. Okay. So we have to go, so we started with negative 541.6. We have to move the decimal point 1, 2 places, right? So that the only number before the decimal point is that 5, or I guess that negative 5. And then the second last step is if you moved the decimal point left, then you're going to multiply this by times 10 to the positive n. And if you moved the decimal point to the right, you're going to multiply by times 10 to the minus n. Okay, so we moved 2 to the left. So our final answer is going to be negative 5.416 times 10 to the positive 2. Any questions about that? Okay, the second skill you need is going the other direction. So say you're given a number in scientific notation. Express it in standard notation. So I'm going to do this with my example number is going to be 6.52 times 10 to the minus 4. The first step is the absolute value of the exponent is what we're going to call capital N. So in our case, n is equal to 4. And then the second and last step is if the exponent is positive, move the decimal point n places to the right. And if the exponent is negative, move the decimal point n places to the left. Okay, so we've already figured out that n in this example is equal to 4. You can see in the original problem it's negative. So we're going to move n places, move the decimal point n places to the left, 4 places to the left. So I'm going to write this number is, we have the 6, 5, 2. And I'm going to start where the decimal point was and go 1, 2, 3, 4. That's the decimal point. Anything in between that doesn't have a number, you have to put in zeros as placeholders. And so that's the answer. Any questions about that? Okay, there's one more thing I want to cover today, and that's unit prefixes. And unit prefixes, I guess the most useful ones, there are a bunch of them. These aren't all of them, but micro, and that's denoted with a Greek letter mu. It looks sort of like halfway in between a script M and a script U. Means times 10 to the minus 6. Milli is denoted with a lowercase m, and that means times 10 to the minus 3rd. Centi, lowercase c, means times 10 to the minus 2. Kilo, that's a lowercase k, means times 10 to the positive 3rd. And mega, which is a capital M, means times 10 to the 6th. And then, in the last couple decades, giga and tera have become important ones. So that's, giga is times 10 to the 9th, tera is times 10 to the 12th. But basically, anytime you see one of these prefixes on a unit, it means that you can replace the prefix with that number, and that's the meaning of it. So in doing calculations, what's the kind of thing that you would have to do? If somebody asks you how many millimeters are there in 5 kilometers, okay? That's 2 cases where you have these unit prefixes. Kilometers are kilometers, So 1 kilometer is 10 to the 3rd times the length of a meter. And a millimeter is using the prefix milli. So that's 10 to the minus 3rd times the length of a meter. And there are 2 things that you have to do when you interact with these, not always, but there can be up to 2 things you can do. Going from something with a prefix to something without a prefix. And then you also sometimes have to go from something with no prefix to something with a prefix, okay? Okay, so I'm going to tell you how to do both of these two things. The first one, so let's say that we're going from a prefix to no prefix. This is the easy one. This is the one you'd like them all to be. Because in this case, so this is easy, you just replace that original prefix with its mathematical meaning. Okay, so for example, let's say that we have 50 kilometers and we want to express that in meters. Okay, so we're going from the thing with the prefix to the thing without one. Well, all we have to do is replace the kilo, that lowercase k, with the meaning of kilo, which is times 10 to the third. And so we get 50 times 10 to the third meters. And you probably want to put that in scientific notation or standard notation. This is sort of halfway in between. So to put this in scientific notation, we're going to divide the 50 by 10. That means we have to multiply the times 10 to the third by 10 if we don't want to change the meaning of the whole number. And so this is equal to 5.0 times 10 to the fourth. If you're going the other direction, it's a little more complicated. It's not too bad. If you're going from something without a prefix to something with a prefix, so let's say we want to know 20 meters. How many microns is that, which is like micrometers? Okay. Well, the way to do this is like a unit conversion. We know that 1 micron is equal to 1 times 10 to the minus 6 meters, because that's the meaning of micro, okay? And so that means there's two possible conversion factors. 1 micron over 1 times 10 to the minus 6 meters, or 1 times 10 to the minus 6 meters over 1 micron. Our starting value is 20 meters. So to do this like a unit conversion, we want to cancel the meters. And so we're going to use the first one of these. So 1 micron over 1 times 10 to the minus 6 meters. You can see then the meters cancel, and you get 20 times 10 to the positive 6, because we're dividing by 10 to the minus 6 microns. And to get that in scientific notation, divide this part by 10. That multiplies the second part by 10, so we have 2.0 times 10 to the 7 microns. Anybody have any questions about that? Okay, let's do one problem. Let me give you one problem to work on, see if you can make sense out of this. Then I'll go through it and then we'll call it a day. So let's say we want to start with 15 millimeters and express that in kilometers. So before you get started on this, I want you to notice that you're going to do this in sort of two steps. You're going to first go millimeters to meters. You're going to go prefix to no prefix. And then you're going to go meters to kilometers. No prefix back to the new prefix. Okay? So take a couple minutes and see if you can work through this. And like always, feel free to talk to each other or ask me questions. So to go from millimeters to meters, we're just going to replace the milli with times 10 to the minus third, the meaning of milli. So you can think of that as like, that's kind of the intermediate step. And then I'm going to do it as a unit conversion to go from meters to kilometers. 1 kilometer is equal to 1 times 10 to the third meters. So we have 1 times 10 to the third meters is equal to 1 kilometer. The meters cancel, and the units that we have are the ones we want. And so this comes out to be 15 times 10 to the minus third divided by 10 to the third. So that's the same thing as multiplying by another 10 to the minus third. I'm sure this is like, you probably haven't used a ton of these exponent rules outside of your math class, but you probably remember that at least vaguely. And so this comes out to be 15 times 10 to the minus 6, because you can think of it as minus 3, and then you subtract 3 from that. And then to put it in scientific notation, divide the left side by 10. That's multiplying the right side by 10 to keep it the same number. And so this is 1.5 times 10 to the minus 5 kilometers. Any questions about that? Okay, so that's it for today. I will look on D2L sometime today. I'll get an assignment up, a daily assignment, and half of you I'll see in 20 minutes.